back to Autoburn. It's been 2 or 3 weeks since my last update. I've not been very well, so progress has been a little slow, but I did get quite a bit done earlier on. First of all, I painted the incline brown to get rid of the nasty white foam. I made a retaining wall to run along the foam. This was made from 3mm foam board and covered with scale model scenery yellow ashlar. I was a bit concerned about the repeating pattern in the ashlar, and it is pretty obvious in the wall, but I think with some weathering it'll be okay. For my birthday I got some Metcalf kits from my daughter, which I've now built up. So we have the Autoburn Primary School, I have some signal boxes and a country station, which I don't think will be the Autoburn station. I think it'll be used for the high level station at the left. I need something a little more substantial for Autoburn. I've also built platforms, main platform for the station and the platform for the branch line. These still need a little bit of fiddling around to get the width right and make sure there's no obstruction as trains go past, but they're pretty close. Some things coming up. I've 3 more of the Oki current sensor boards to make up, which will then let me get blocks throughout the entire layout. We've got Mardec Accessory decoders, which I'll come on to later, and I've also bought model signal engineering home and distance signals as brass etches, and I think I might have bitten off more than they can chew. I think I'm going to certainly have to invest in a better headset magnifier before I start tackling these. They are tiny. And now for a small break. Last weekend was the first open day of my brother's Quercus Light Railway, a 16mm narrow gauge outdoor railway, which is near Peebles in the Scottish borders. It was a good day with 4 or 5 people turning up from the Scottish 16mm Narrow Gauge Association and other places, and I've got a few pictures of or videos of trains running on the layout in the borders, so I'll show those next. And just before that starts, the blue Mamod or MSS loco and coaches that you'll see is mine, and was running rather well that day. So David will be running open days at the Quercus Light Railway on the last Sunday of each month through the season. So I'll put some details in the description, and anyone who is able to get to Peebles would be very welcome to come and see the trains running. And of course, if they have any 16mm narrow gauge or O gauge that's battery powered, they can come and run it on the 140-foot circuit. The other main area of progress since the last update has been fitting all of the servo point motors, and I had them all wired up and working with a Mardec accessory decoder, but there was a problem in that when trains were running, noise was being picked up on the signal wires of the servos and causing them to jitter. So I've decided to make up 2 more Mardec accessory decoders, which we'll see in a minute, and I will then be able to have much shorter signal wires, as I can have 3 decoders spread around the layout and keep the signal wires as short as possible, and I hope that will solve the problem of jittering servos. So I've now got a short segment, well, hopefully short, of how to assemble the Mardec accessory decoder, and I'll come back after that. Okay, so I'm going to show you how I assemble a Mardec accessory decoder. This is produced by Arco Mora, and when it arrives you get a little plastic bag with a bunch of components and a printed circuit board. This is pretty straightforward to assemble. Assembly instructions are downloaded from the website, and the first thing you spot with the Mardec is that there are 2 options with assembly. You can assemble the board with an onboard 5-volt regulated power supply, which you can feed from AC/DC accessory bus, or you can omit that if you're going to be using external power for your accessories. In this case I'm using it with servos, and I have a 5-volt bus for the servos. You could use the accessory decoder with LEDs or relays or all sorts of other options. So there's not a great deal to assemble with this. The tools we're going to need is a soldering iron. I have a temperature controlled one, a pair of snips for removing excess leads, and solder. I see a lot of people with model railway channels saying how difficult soldering is, or that they don't enjoy soldering. There's a very simple solution to that. Get some traditional tin lead solder. You then don't need flux. You can solder at a lower temperature, which is beneficial when dealing with electronic components. It's just much easier. I don't want to get into details about safety, but just suffice to say that lead-free solder was introduced as an environmental issue. It was nothing to do with the safety of using lead solder. It was to do with electronic circuit boards being disposed of in landfill and lead leaching out. So lead-free solder, tin lead solder makes life very, very easy doing electronics. A printed circuit board is nice and clear with all of the components marked, and also orientation for things like diodes where it matters. So we'll make a start. Generally, for electronic circuit board assembly, you start with the components the flattest to the board and then build up in height. So we'll start with the resistors and the diode. There are 6 resistors, 2 kilo ohm, 2 10 kilo ohm and 2 330 ohm. The colours are in the instructions and you can just about see them. A quick tip is to use a multimeter and double check the values before you start. So I have 2 kilo ohm resistors, which are resistors 1 and 6. So we put those in the right holes. 1. Bend the legs. And 6. I'll just turn that one round. Just a personal thing, it's not at all important. I tend to put the resistors in the same way around so it's easier to see the colours, and just slightly bend the legs over at the back. So the second is resistors 2 and 3, which are 10 kilo ohms. So we'll find those. Conveniently they're close together as well. Resistor 2. Oops. I can't see. The colour bands are different on those two, but I think that's correct. Yep. And the last 2 are 330 ohms, which start with orange, and they are resistor 4 and resistor 5, which I can't see for looking. Up here, these are used for the LEDs. Resistors are fairly tolerant of temperature changes, but the diode isn't. So I prefer, when soldering these in, to solder one end and then solder the other later to allow the component to cool down a little bit. So we have a diode here. I'll put that in the same time with the resistors because the diode is more temperature sensitive. The diode has to go in the correct way around. It has a black band at one end and the circuit board shows where the black band goes. So that's our first layer of flat components ready to solder. And with, say I go around them oops. One leg at a time, which allows the component to cool before we do the next leg. What I am missing is my solder tip cleaner, which I'll find in a second. Now we can trim the legs. So the next stage is to solder in the integrated circuit socket, which is slightly bent legs, so we'll straighten those up. And goes in here. You can see that there's a notch on the printed circuit board and a notch on the socket, so we ensure they're lined up correctly. Okay, problem resolved. I had to drill out the hole with a micro drill to get that socket in place, but now we will solder that in place. Trick with sockets is to solder one corner and then the opposite corner first. And then check that the socket is flush against the board, which in this case it is. If it wasn't, you can or melt the solder on the corners and push it flush while the solder is still soft. And that's the socket in place. We now have to put in the 100 nanofarad capacitor, which is C2. So we'll find C2 is there. And it looks like this might have a little bit too much flux on a pin as well. So we'll just, there we go. Capacitors again aren't overly sensitive to temperature, but we will just give it a second before soldering the other leg. Okay, so the next stage is the LEDs. We have a power LED and a status LED. Right, okay, power LED should be green. LEDs have one long leg and one short leg. And the short leg is nearest to the edge of the board, so that way around. And the yellow one, the same, short leg outside of the board. Once again, do one leg of each component at a time. LEDs are sensitive to heat. There we go. Okay. Now suggests putting in the chip. And the chip has a little chunk out of one end. Now these usually have either a white dot or a little cutout at one end as well to indicate which way they go. This one doesn't, but I did look it up, and if the text is the right way up with the cutout at the left, it'll be the right way around. The legs are always splayed out too much to fit into the socket, so we need to first of all just bend them slightly. Whoops. against a flat surface. We need to be very careful here. We want to make sure that the pins don't end up folding under. So again, double check the right way around, and gently push it into place. Double check that nothing's folded under. That looks fine. And that is the electronics part done. We now have some connectors to solder on. So we'll start with these. We want the blocks with the terminal connectors outside. And the 2-pin one goes on in the DCC position. Again, we'll pop these down. And similar to the others, solder one corner or one end first and check that it's flat. Oops, more solder on there. And if necessary, adjust before soldering the rest of the pins. That's okay. Yep, they're all okay. And the next stage is to put the terminal headers onto this board. Now the easiest way to do this is to put them first of all into the Arduino Uno. So we need to cut there. So we push all of the headers firmly home and then sit the board on. It'll only go one way round, which is that way. And what we do here is back again, do corners for each of the blocks, but we don't solder all of the pins because we don't want to transfer too much heat to the Arduino. So we'll just do each of these. And then remove the shield from the Arduino. And as you can see, one of them has slipped, but that's okay. Make sure that the blocks are nice and firm against the board, which they are, and then we'll solder the rest of the pins. This is one area where it's easy to make a mistake. These pins are very close together and you can end up with a bridge of solder between two of the pins. If you do, the way to fix it is to go back afterwards with the soldering iron, draw the soldering iron between the two pins and remove the excess solder. And then if you want to be doubly sure, use something to scrape between the two pads to be sure that there isn't still a bridge of solder. And there we have it, a Mardec accessory decoder, or at least it is with the two parts together. The next stage is to download the software to the Arduino from the Akamora site, and then you connect everything up and use a USB connection to the Arduino and a terminal program to configure the pins that you're using and what you're using them for, and connect DCC to the board. The optocoupler acts as isolates the DCC signal from the Arduino, so the DCC signal, which might be 18 volts, is converted to plus or 0 to 5 volts by the optocoupler, which is effectively a fast LED and a light detector in the block, so that as the DCC signal goes up and down, the LED flashes, the light detector picks up the flashes and converts it to a 5 volt signal that is used by the Arduino. So that's it. I hope, slight problems aside, that shows that it is pretty straightforward to build an accessory decoder for DCC, and in this case relatively cheaply. The Arduino, this is a standard Arduino Uno, but you can get an Arduino Uno clone from Amazon or eBay for around £5, and the Mardec DCC Power Shield is, I think, €4.75 from Nico at Akamora. So I've now assembled 2 additional Mardec accessory decoders, and the next job is to fit those and wire up the servos and test that the jittering is gone. After that I'll make up the sensors, occupancy sensors, and get those wired in as well, and then hopefully I can tidy up the wiring under the baseboard and be done with it for the moment at least. Other things to look at, that'll be these signals, station building for Otterburn, and after testing the track thoroughly I can start looking at ballasting the rear side of the layout at least. So hopefully that's what we'll see in the next update. Thank you for watching. Please subscribe, ring the bell and all that good stuff, and hopefully catch you soon. Bye.